Hi class. So we are doing part 3 of our review unit 4. So the question we are on is number 18. It says the following situation could be modeled by a linear function. Write an equation for the linear function and use it to answer the given question. Be sure you clearly identify the independent and dependent variables, then briefly discuss whether the linear model is reasonable for the situation described. So the cost of leasing the car, the cost is going to be one of the variables. And then it is $800 for the down payment. So you just pay a constant fee of $800 at the start. And then every month, you're paying $330 per month. So every month you pay that. For how many months can you lease the car with $3,390? So the cost is going to be dependent on how many months you lease the car. So months will be independent. It's this one. The independent variable is time, and then the dependent variable is amount paid in dollars. And then the function is going to be the price equal to, and how much is that? You're paying $800 down, so you need the $800, and then plus, and then every month you're paying $330, and we'll use T for time because that's what it says here in time. So that's our first question. And then the car can be leased for how many months for $339? Well, we're going to use the screen capture. Sorry, let's see if that works. Oh, there it goes. Okay, so we're going to use this formula that we just came up with. $800 plus 330 times T is equal to $33.90. And first thing we'll do, of course, is subtract 800 in order to solve our equation. 330T is 3390 minus 800. Helps if I don't have anything else typed into the calculator. So that's 2590, and then divide by your 330. Divide 330, and that is 7.8, I believe. So 3390, let me just check my work because I don't have anyone to find my answer. Yep. All right, so I get 7.8. So you don't quite get 8 months. You're going to have to round down to 7 months. So let me type that in because you won't be able to make it all the way to 8 months. 7 months. All right, that was 18. Oh, we still have a question to answer. So is it reasonable for the situation, for the linear model? I would say probably yes. It's reasonable because buying a car usually consists of a down payment and constant monthly payments. So I'm like an A, because your down payments are there, but your monthly payments do not decrease over time, so it's not B. It only consists of a single payment. Don't we all wish? It's not C. And then because buying a car usually consists of a down payment and monthly payments that increase over time, it can't be D either. Generally, they don't increase or decrease, and they definitely aren't a single payment, as much as that would be nice. All right, next one we're going to do is 21. All right, so find the degree measure of the angle that subtends the part of a circle. So if I have 1/4 of a circle, what I need to do with that is I multiply 1/4 of the total degrees. And as we know, the total degrees is 360. And if I take 360 divided by 4, that's going to be 90 degrees. Pretty simple. So all you do is multiply your 1/4 by the total 360. And 90 degrees, 1/4 of the circle. And the next one we're going to do is 22, which is right here. So find the circumference and area of the circle. Now for that, you're going to need a couple of formulas. And I'm going to do the screen capture and I'll do that real fast. So, we have a nice radius, 1. That's pretty awesome. So the circumference is 2 pi r. So we're given it in radius. So 2 pi times 1, which is 2 pi. And then the area is pi r squared, which is pi times 1 squared, which is pi. So 3.1 for the area. And then 2 pi, it's going to be 6.3. if we're rounding to the nearest tenth. So circumference, I forget, 6. Let's see, do I have that? I'm going to just get those two numbers in my calculator so that I can type them in. The circumference is going to be 2 pi r, so 6.3 rounded to the nearest integer, and that's just going to be inches because it's just the length, it's not an area. And then the next one is area, and it's just 3.1, just pi. And areas are squared, so we need to make sure that we include square in our area. Pretty simple. All right, 24. 24. It says the water reservoir for a city is shaped like a rectangular prism, 270 meters long, 80 meters wide, and 12 meters deep. At the end of the day, the reservoir is 90% full. I'm going to draw this reservoir here. 90% full. How much water will be needed to be added overnight into the reservoir? So we have 270 meters long, 80 meters wide, and 12 meters deep. So our volume is going to be 270 meters times 80 meters times 12 meters, which is going to be 3 meters multiplied together is meters squared, and then 270 times 80 times 12 is 259,200. So that's how many cubic meters we have, 259,200 cubic meters. Now, if we want it 90% full, we want it 100% full and it's already 90% full, we want to know how much needs to be added to make it 100% full if it's already 90% full. So what we need to add to it is 10%. So what I'm going to multiply that by is 10.1 as a rate. And that's just going to knock off 1 0. So I'm going to get out of this and then type in 25,920. And we need cubic meters added to fill up our 90% full pool into 100%. All right, next is 25. So 25, suppose you magically tripled in size. Oh dear, I hate these. It's so frustrating to figure out how much you weigh after you triple in size. Anyway, that is your height, width, and depth increased by a factor of 3. By what factor has the amount of material required for your clothes increased? So we know clothes are an area, they're surface area. So when we're dealing with surface area, we take our original factor, our length factor, or perimeter factor, and we square it. All right, so because it's an area. Material is surface area, as we know, right? So it's going to be 9. We're going to increase by a factor of 9. Oh, these are just really easy. Getting a lot done. All right. And then next up we have number 27. So convert the given degree measure into degrees, minutes, and seconds of an arc. For that, I'm going to bring my calculator maybe over. Let's see if it will come over. Let's see. All right. Boy, but it sure is. Now can we see it? That light is just funny. I have a lot of stuff going on over here. All right, so let's zoom in. Maybe that will help. Take that little glare off. No, just kind of increase the glare. It's not really. Oh, I got things moving all over the place. Okay. I think you can mostly see it there. Probably. All right, so what we do when we're converting to DMS, which we call degree, minutes, seconds form. So 31.7, we put it in the calculator, and then you go to your angle menu. So second angle. And then on number 4, it says convert to DMS. So we hit 4, and then we hit enter. That's so easy. It took me longer to figure out how to get my screen shot over here than anything else. So anyway, we have 31 degrees, of course, because the 0.7 is going to break it up into minutes and seconds, but the 31 degrees remains constant. And then 42 and 0 seconds. What our calculator said anyway. All right, nice job. And then next is, that was 27, 29. It says, find the latitude and longitude of the location on Earth precisely opposite of a town located at latitude 48 degrees north, longitude 107 degrees west. All right, so what we do with these, if we're moving straight across from a point, oh, it's north, so 48 degrees north, 107 degrees west. So if we're up here and we go straight through the Earth, okay, and come out on the other side, however far we were north, we're going to be that same distance but south, so 48 degrees south of the equator. And then if we were 107 degrees west, going straight through is going to take us to east at 180 minus 107 degrees. So 180 minus 107 is 73, so it'll be 73 degrees on the east side. So we need southeast, which is the first one. 48, 73. So 48 degrees south, and then from west to 180 minus 107 east, which is 73 degrees east. All right. I think we might have time for another one, 31. So 31 says, find the angular size of a circular object with a 2-inch diameter viewed from a distance of 6 yards. So those angular size, we have a specific formula that we need to use. And, I need to be able to write this down. So your angular size is going to equal your physical size times 360 degrees over 2 pi distance. And that's your formula. So all we have to do now is plug in all of our information. We are looking for angular size. So our physical size, we have a little problem here, don't we? We have 2 inches and 6 yards. They're not in the same units. So in order to come up with inches, we'll just put them all in inches. Let's see, 6 yards times, we need 1 yard on the bottom, and that is 3 feet. And then we need 1 foot on the bottom and 12 inches on the top. And that way our yards divide out and our feet divide out, and we have a conversion at 6 times 3 times 12 inches. So 6 times 3 times 12 inches is 216 inches. That's how many 6 yards is in inches, so that we have our units matching. Okay, so our physical size is this, our 2-inch diameter, times 360 divided by 2 pi times our distance, which our distance is 216 inches. All right, now the 2 inches divide out, and we're left in degrees. So it's going to be 2 times 360 is 720 degrees over 2 pi times 216. And I'm just going to use my calculator. We've done this over and over again. Set up a little fraction, put in 720 over 2, and you can just put it in just as you see it. 2 pi 216, no need for times symbols because calculator doesn't need it. We're going to have to round. So about 0.53. It says round to the nearest hundredth, so that's what that is. And I can type that in, 0.53. And that's your degree. It's about half a degree that your angular size will be. So blocked vision. All right, we are out of time. So we're going to stop there, and I will upload this one, and we'll move on. We have one more probably.